Okay, today we are continuing on with section 1.5, which is properties of real numbers. And remember, we're focusing on the real numbers, not the imaginary. There are numerous different types of properties with real numbers, and each of them have their own special names. I'm going to just kind of go over these. Once again, just like with this, anything in this class as far as definitions, I will never ask you what a definition is, but I expect you to know what it is and how to apply it. So the first thing that we're going to cover is what's called the commutative property. And you'll hear me refer back to these over and over and over again until hopefully they just become kind of second nature to you. But is the commutative property of addition. Now, there's this long drawn out definition of this. Basically, it's just saying that changing the order of numbers in a sum will not change the results. I'm not going to write all that out, but what I'm just going to show you is the example of that. Basically, it's telling you that if A plus B is equal to B plus A, and all that means is I can change these numbers around, but it's not going to change the answer. And what that means is if I substitute these in for numbers, 3 plus 6 is the same thing as 6 plus 3. Now, the reason that's important is because when you're adding and subtracting numbers, sometimes, for an example, if I say that negative 3 plus 5, I have to do my two-step process. These two numbers don't match. I subtract. 5 minus 3 is 2. Because the 5 is bigger, it's a positive, so my answer is going to be positive 2. But a shortcut to this sometimes is if I can just reverse these numbers. Because to me, it's way easier to reverse these numbers and say 5 minus 3, oh, I know 5 minus 3 is 2, and that's a shorter way of figuring it out instead of doing two steps. So I'll let you choose which one you want to do for those. Both of them will give you the exact same answer. The next one is a commutative property as well, but this one is the commutative property not of addition, but of multiplication. The commutative property of multiplication is very, very similar. All it is telling you is that if I multiply A times B, it's the same thing if I multiply B times A. So once again, I'm going to substitute in numbers. I'm going to use the same numbers because we're already using 6 and 3. So that's basically telling you that 3 times 6 is the same thing as 6 times 3. So if I multiply these, they're both going to give me 18. So that's saying I can move them around. Now, the reason that helps you out is because when you're working out problems, it allows you to kind of reduce things a little bit easier and allows you to move things around. And I'll kind of show that a little bit later. But basically, notice that these are multiplication and addition. Now, the other two operations, subtraction and division, they are not commutative. Only addition and only multiplication can be changed. And the reason for that, so for an example, I'm going to use A and B again, except for this time, instead of saying A plus B, I'm going to say A minus B. So we're just going to use the same numbers, 3 and 6, and we're going to say is 3 minus 6 the same thing as 6 minus 3? Well, once again, let's just take a look. Use our two-step process. These don't match, so 6 minus 3 is going to give me 3. The 6 is bigger, it's a negative, so this answer is going to be negative 3. On this side, once again, these two don't match. They're positive and a negative, so 6 minus 3 is going to give me 3. The 6 is bigger, it's a positive. So notice how it doesn't give me the same answer. Hence, it does not work for subtraction. Also does not work for division. So once again, if I just say 3 divided by 6 is not the same thing as 6 divided by 3. Reason for that, 3 divided by 6 will actually give you 1/2. I'm not going to work out all the math, but 6 divided by 3 will give you 2. What you will wind up with, and these two are the reciprocals, right? But we need them to match in order for this to work. The next property that we have is just called the associative property. And I'm sure you're familiar with these, you maybe not with the terminology, but the associative property of addition. And the reason why, like I said, that these properties are important is because it allows you to solve problems and move things around. So basically what this is telling you is that changing the order of the numbers in a sum will not change the result. So what that means is if I say A plus B plus C is equal to A plus B plus C. Right? So that's a bunch of letters. Maybe that doesn't make sense, but let's just substitute in some numbers. It's telling you that 4 plus 2 and then adding 5, remember we always do what's in parentheses first, is the same thing as adding 4 plus 2 plus 5, right? That's telling you it's this exact same thing. So let's work out and see. 4 plus 2 is 6. It's going to give me 6 plus 5. 2 plus 5 is 7. So 6 plus 5 is 11. 4 plus 7 is 11. So these are the same thing. So it's just telling you can move them around when you solve them. Now, it also works for multiplication because there's also the associative property of multiplication. And it's basically telling you the exact same thing. It's telling you that A times B times C is the same thing as A times B times C. Once again, we're going to use the same letters, our numbers, we're going to substitute them in. This is telling you that 4 times 2 times 5 is the same thing as 4 times 2 times 5, grouped together. So once again, let's just prove that. 4 times 2 is going to give me 8. It's going to give me 8 times 5. Once again, on the other side, 2 times 5 is going to give me 10. So if I work these out, 5 times 8 is going to give me 40, and 4 times 10 is also going to give me 40. So all it's telling you is that you can move these around to any order that you want and that it does not matter. Now, if I'm working these out, I'm just going to work these out a little bit. I'm just going to do a quick problem. Well, actually, we'll wait on that just a second. So for the next one, this is just going to be the first half of this section. This is probably one of the longer sections that we do. But anyway, number 3, and also that the associative property does not work, once again, with subtraction and division. Then we have what's called the distributive property. So the distributive property is basically telling you that multiplication distributes over addition. Now, what that is telling you is that if I have A times B plus C, that is the same thing as AB plus AC. Now, once again, maybe these letters don't make a lot of sense, so let's just use our numbers. That's telling you that 4 times 3 plus 2 is the same thing as 4 times 3 plus 4 times 2. Once again, let's just work this out and see if that works. Once again, following PEMDAS, let's work what's inside the parentheses. That's telling you that it's going to be 4 times 5. We'll go ahead and work that out. That's telling you that that's going to be 20. 4 times 3 is going to give me 12 plus 4 times 2, which is going to be 8. 12 plus 8 is going to put me back at 20. So it's very, very similar. Or not similar, it's the exact same thing. So if I'm working out these problems, once again, it's just telling you to distribute. And you'll hear me say that over and over again. That's part of our properties in solving, and this is kind of jumping ahead to chapter 2 and 3. But when you distribute, you're just kind of solving your problem a little bit.